Hi everyone, I'm Nicolas. I do red teaming, and that presentation today will be about BadUSB attacks specifically on macOS. So, before talking about BadUSB attacks on macOS specifically, maybe let's quickly explain what they are in general. So, in BadUSB attacks, you make use of a specialized USB device. It could be a rubber ducky or a flipper zero. And what happens is that it will be seen as a keyboard by your victim's machine. And basically, instructions are stored on a device using some scripting language, a specialized scripting language. In this case, it would be it could be ducky script. And basically, it sends a series of pre-scripted keystrokes to perform some actions on the machine. In our case, we try to plant a malware on the machine. So in our case, it would allow us to easily get a foothold on a machine whose owner was absent-minded and didn't lock their machine and walked away from the machine. On Windows, it's usually made a bit easier than macOS because there are more features accessible using keyboard shortcuts, at least interesting applications. So for instance, you could talk about maybe the task manager. So only using a keyboard, you might be able to actually perform a dump of some processes. A common technique would be to perform a dump of the local security authority process, get the memory, and then it could be used for hash cracking, for instance. The run dialog is the most interesting one for sure. We can invoke it using the Windows plus R keyboard shortcut, and you can run any binary, including arguments. So actually, it sounds trivial, but it will be important when we look at the differences with macOS. And there are some very nice features. For instance, you can run a PowerShell window with a window style hidden. And it can be very good in the context of BadUSB attacks. Because let's say your PowerShell script is going to do a lot of things. It might take some time. You want the window to be hidden when you walk away, so that the victim will not spot your window that is open and doing some unknown things. So that's a few examples of how BadUSB attacks are performed on macOS usually. Now that we've seen BadUSB attacks in general and some examples on Windows, let's talk about some macOS features that are not exactly protection against BadUSB attacks, but they can nonetheless get in our way. So the first of them is the keyboard setup assistance. So it triggers whenever you plug in a keyboard that is not from Apple, and that identification is done via a device ID that you can advertise. And fortunately, we can actually spoof it using a special directive, so ID. You can see at the bottom of the slide. Using this, you can actually spoof the device ID of a Mac keyboard. So you need to do that. And also, take note of this. It's only on Apple Silicon platforms, so your M1, M2, etc. Whenever you plug in a device that is USB or Thunderbolt, you will get this pop-up. And it's not exactly a protection against BadUSB attacks. It's more about, I think, the evil airport charging station scenario. So basically, the user will be able to choose whether they want any data transmitted to this device at all or none. But the thing is, it's actually not that big of an issue, right? Because when performing a BadUSB attack, usually you're in physical proximity of the victim's machine. And you can actually simply press enter, return on a MacBook. So you're very close and it's very quick. So it's not a big issue. But just don't forget about it. here we go over some common examples of BadUSB scripts for macOS and why it might not be suitable maybe for my use and in a red teaming use within real-life red team engagements. So usually it always starts from here. So there's going to be a spotlight search, and so spotlight is used to look for different kinds of files, of items, applications, etc. And we are particularly interested in applications, so we can use it to find application and open it. So usually what they do is that they invoke a spotlight search, they search for terminal app, and they open the terminal app and then issue shell commands in it. So yeah, so some examples of flipper 0 BadUSB scripts you might find online from macOS. So as usual, you start from a spotlight search, you open the terminal, you type some shell commands. Optionally, you have some features, let's say, not having your commands written in the history or removing some entries. But in the case of an EDR monitoring process executions, it's not very useful for you. And actually maybe the main issue as well is, does it actually work in a real life scenario? Because in the end, it depends on your victim, right? So your victim might be, if we take like all the cliches about Mac users, could be a graphic designer. It's unlikely they use a terminal, to be honest. So maybe, yeah, this kind of attack will work. But if they are like engineers, like SRE, developers, you name it, it's very likely they use a terminal. And the reason why I'm talking about this is that the way Spotlight behaves when you open an application, at least for a terminal, is that it has already an instance, a terminal open somewhere. It's not going to open a new one. It's going to switch the focus to that window. And so if your victim was doing some work in a terminal, then it's going to interfere with their work. So potentially interfering with some long-running process, or maybe you're going to close the window, close the tab. So it's not something you might want, because ultimately, if you're an internal red teamer like me, it's still your colleagues, so you don't want to make them lose their work or that kind of things. You may get lucky if these people actually use a third-party terminal application. So it might be common that people use apps like iTerm2. So in this case, you will get lucky. So I'm using a script editor and Apple scripting languages. So this is where we will diverge from the usual examples we see online, that open a terminal from Spotlight and use shell commands. So let me present what a script editor application is. So you can see an example of the window here. It's an application present on macOS by default. You have the official description here, but put simply, it's just used to create automation scripts. You can write your scripts in two different languages. So you have Apple scripts, which is a bit closer to natural language, and you have JavaScript for automation, aka JXA. And as you can see on the window, Apple script, I mean, if you can see, yeah, I think you can see, Apple script is selected by default. Yeah. The main issue with these scripting languages is that it's actually fairly limited in terms of what you can do. Fortunately for us, there is a feature called the Objective-C bridge. So it's called AppleScript Obj-C for AppleScript and JavaScript Obj-C for JXA. And in the case of JXA, for instance, you will find a lot of thread crafts online created by people from the community. And it's mostly done in JXA, and it's usually also making use of that Objective-C bridge. So yes, we could reuse that existing JXA threadcraft available online, but unfortunately, like I said earlier, AppleScript is the default language in a script editor. So we have no choice but to use it, at least for now. So we'll find a solution to this problem later. So let's start with the loader. So I didn't want to type too many characters on the screen, because in the end, let's say you're in open space, and it might be very weird if someone noticed that there are like so many characters being written at a inhuman speed on the screen. So I think the shorter the better. So that's why I created an AppleScript loader. So essentially, it will use a functionality in AppleScript that will allow you to evaluate AppleScript as text and execute it. So in our case, basically, we will fetch our main AppleScript payload from a remote location, and we'll execute it from the script editor. So it has a few advantages. I think the first one, I already mentioned about very few characters being typed on the screen. And the second one is that if you want to make changes to your main payloads, at least you don't need to change your flipper0 script and then upload it to your device again. So it's more convenient. So remember a couple of slides earlier, we said we would like to reuse JXA tradecraft, but we are stuck with AppleScript. Actually, we are not exactly stuck. There is a feature. So when you use run script, you can actually specify the language. And if you specify JavaScript, it corresponds to JXA here. So we can actually execute JXA in the context of an AppleScript script. So we created some helper on the screen. It's very easy. We're going to reuse it later. Exec JXA. So first step, we might want to compromise. We want to compromise the machine, right? So, and we want our malware downloaded. So we need to fetch it first. We don't want to use curl, because curl is like an obvious indicator. So in this case, we want to use, the possibilities offered by the, Objective-C, language. So we're going to use NSURL and, NS data classes. And actually, we did the same thing with our loader just now. And our malware will be downloaded to our chosen location. Then, if our malware is a binary, so for instance, in a scenario that we will have later, is going to be a Poseidon agent, so it's written in Golang. And to execute it, we need to make it, to issue some sort of chmod plus x function, command. I tried to implement it in AppleScript, but I ran into some issue, and I know that I was feeling lazy. So it was the right moment to actually reuse that execJXA function. And someone had implemented the very same chmod function online. So I simply passed it to execJXA, and it worked. That was from the persistent JXA project. So let's create a launch agent now. So launch agents are a persistence mechanism on macOS. It's pretty common actually. They are plist files, standing for property lists, and use XML syntax. We can actually drop the plist file into a designated location. So in our case, it will be in library/launch agents within the users folder. Another thing to take note of is that the library/launch agents within the users folder is not created by default. So you might need to check for its existence first and create it if it doesn't exist. And now from the malware execution. So here we have multiple strategies. So basically we can wait for the next startup, because we already have persistence. In which case our launch agent will be simply run by launchd. We can also use the launchctl utility, which is pretty usual to interact with launchd. Usually it's like launchctl load -w and the path to your plist file, but it might be also a signature in itself. In the end, we went with executing the binary directly by using an NS task. So you can see an example on the screen. There's a small caveat with this. If you remember in our launch agent definition, we had something called keep alive. And keep alive basically makes it like a service that if the binary that's part of the service dies for any reason, it will be automatically revived. Since at the first execution we are executing it directly or in a more conventional manner, it won't be part of launchd. So if it dies during the first run, you won't be able to get your callback back until the next startup. So it's just a small caveat to think about. Yes. So now we have written our script in the script editor window. We run it, and at the end, when it completes, we need to exit the window. We cannot let the window open for the user, right? So to do this, we quit the script editor, and then there will be a pop-up on the screen which asks you whether you want to save the draft. And obviously, we do not want to save the draft, right? So the right shortcut for this is Command plus Delete. So it's exactly what I wrote in my flipper0 BadUSB script, and it didn't work. So let's check why. So I created some small Python scripts, which basically will print on the screen which key you have just pressed. So I pressed the delete key on my MacBook Pro, and it actually told me that it was a backspace key, which I guess kind of makes sense because the delete key on a MacBook Pro clearly behaves like a backspace key actually. So let's make the change. So this is the final flipper0 script. I'm basically piecing together everything I thought about before. So I'm advertising a Apple keyboard device ID. I'm doing the spotlight search using cmd plus space, looking for script editor. I'm copy pasting the loader, running it. Then I quit the script editor and discard the draft. So that's pretty much it. Alright, I think it's demo time. It works? It works. So we had no callbacks on our C2. Now I launch the attack, spotlight search, script editor. Okay, it's already written. It's executing. Then we discard the draft and we got a callback. So the actual attack, so from when I press the button to we actually get a callback, I think it was around 12 seconds all in all. So it's not too bad. Okay, so enough with offense. Let's talk a bit about defense as well. So the first question you may want to ask yourself is, do we actually need this application in our environment? I doubt quite a bit that your users would use it. But yeah, basically you need to basically see if it's used in any part of your organizations. If it's not, then there's no point leaving the access to this application. You can try some detection. You can try to write some detections, but if you only do it on the fact of running this application, you will get a lot of false positives. It could be someone like a first-time Mac user who just clicks around, open everything, and then you will get an alert. So it's not scalable. It's not going to work. And I would totally do this. So yeah. You can consider restricting as well access to the application. I think some corporate device management solutions allow you to prevent access to some applications for users. So it could be one way as well, I guess. And more on the detection opportunities. I think we can look for these events that definitely, I think, look suspicious. So we have process execution events of ad hoc signed binaries. So it means it didn't have a proper developer signature. It could be file creation events leading to the creation of the user's launch agent folder, and file creation events as well when you can see a file is created within the user's launch agents folder, or actually any other non-persistence location. So yeah, I forgot to say it, but it's written on the slides. All these events, you filter them by stipulating that you want them to originate from the script editor process. Yeah. And a last potential way to, I mean, it's not detection here, it's more like prevention. If you want to, if you want to play with your potential attackers, red teamers, you name it, we all know that it always starts with a spotlight search and using the CMD plus space key, right? So why not modifying it and just use another keyboard shortcut? Then if you get attacked, it's going to use CMD plus space very likely at the beginning, and it's just not going to work at all. So from the very beginning of the attack flow, it's going to be it's not going to work at all. Yeah. I think that's it for me. Thank you.
All right. Thank you, Nicolas.